All right, we're going to work on writing systems of inequality. So what that means is that we're basically doing word problems. So we're doing more systems of inequalities with the graphing and the shading, except we have to write the equations first. So first one, let me get myself organized here. All right, suppose you can work a total of no more than 20 hours per week at your two jobs. Babysitting pays $5 per hour and your cashier job pays $6 per hour. You need to earn at least $90 per week to cover your expenses. So since we're going to be graphing, you might want to use X and Y instead of using like B for babysitting and C for cashier job. Okay? Now, it doesn't entirely matter, but I think really whatever you're most comfortable with is good. So let's just say that we'll say X is going to be representing our babysitting job, and we'll say that Y is our cashier job, because those are the two variables that we have going on in here. All right, so now we need to write our two equations. So babysitting pays $5 per hour, cashier job pays $6 per hour, and we need to earn at least $90. So here, we'll do some color coding here. Sorry, I kind of forgot. Let's put all of the money together. So it's $5 per hour babysitting, cashier is $6 per hour, and we want at least $90 per week. So I'm thinking oh gosh, look at what I just did. 5b, okay, we'll make that an x. So 5x plus 6y, which is our cashier job, we want at least $90, which means we want $90 or more when we are done with our work. So $5 for babysitting plus $6 for cashiering, and we want to make $90 or more. So that's the greater than or equal to 90. All right, now the other information that we have in here is that we can work no more than 20 hours. So what that means is that if we take our babysitting hours plus our cashier hours, it has to be less than 20 hours each week. So that number up there, no more than 20 hours, means that I have to work less than 20 hours. So now we have our two equations. Okay, so now we got to go over to graph, and typically you guys are used to doing y equals mx plus b. I want to show you how to graph with your x and y intercepts, because I think that that's going to be a lot easier on the inequality word problems because of the numbers that we are dealing with and the fact that not everything is divisible, so we'll end up with some fractions over here or just large numbers anyway. So our graph is not going to be a traditional 1 through 5 kind of graph, because you can see here that we're dealing with 20, and over here we're dealing with, well, it's 90, but it wouldn't be after we solved it. But what I want to show you is how you can get your x and y intercepts. So if you remember, I'm just going to kind of go to the side over here for a second. If this is your graph, your x and y axis, this right here is your y-intercept. And what's special about that is that it always is 0 something. So that means that the x is 0. So if I go over to this problem right here and fill in x with 0, 5 times 0 is going to be 0. So this right here will then give me what my y-intercept is, which if we divide both sides by 6, because basically what we're doing is we're solving. If we divide both sides by 6, then we're going to get 90 over 6, which doesn't work out perfectly there. So if you think about reducing it, or you could even just change it into a mixed number. Let's go with reducing it first. But 6 will go into 90 15 times. So what we're trying to do here is to get this down to be, well, if possible, a whole number would be great, but if not, then we just want to reduce that down or make it into a mixed number. All right, so now we know that the y-intercept is 15. All right, now let's go back over here to the side again. If we had our x-intercept, that would be this point right here. And what's special about that is that it's always something 0, which means that the y is always 0. So if I go over here and I want to figure out what the x-intercept is, then I'm going to fill in 0 for the y. So if y is 0, 6 times 0 is 0, 5x plus 0 is still just going to be 5x. So again, I would just divide both sides by 5. So I would end up with 90 over 5, which then what we're going to want to do is write that as a mixed number or reduce it, whatever is possible, basically. And 5 will go into 90 18 times. So now we know that the x is 18. So this tells me that this point right here is going to be the point 0, 15, and this right here is going to be the point 18, 0. And since I have 2 points, I can make a line. So now I'm going to go over to the graph. And something else that's unique about these word problems is that there really is no need for anything outside of the first quadrant. And if you think about it, it should hopefully make sense to you that we don't need anything outside of the first quadrant because we're only dealing with positive possible values. All right, so I need to graph 0, 15, and 18, 0. So for my graph, I'm going to go by 2's. So 2, 4, 6, 8, there's 10, 12, 14, 16, 18, there's 20. So now I can graph the point 18, 0 is the point right there. And then I'm going to go up by 2 as well. So 2, 4, 6, 8, here's 10, 12, 14, 16, 18, 20 is right up there. And I need 15. So 10, 12, 14. So 15 is right here. So 0, 15 is right there. So now I know that my line is going to go right there and hit those 2 points. All right. So now we need to go back over here. Hopefully you remember that this symbol right here tells you that it should be a solid line and shaded above. So we want a solid line shaded above. So solid line, I think I'm just going to use my paper here. I don't think I'm going to chance drawing a perfect line there. All right, so there's the solid line, and we are shading above. So that's going to be all up here, because I want the y values that are greater than the line. So that is all of this. And again, we don't need to go into the negatives because it's not going to make sense for you to work a negative amount of time. I'm not really even sure how that would work, but whatever. Let's not even think about it. So we are showing all the possible hours that you could work and make above $90. All right. Okay, next equation is the blue one. So we're going to go through and do the same thinking, the same steps here. All right, instead of doing y equals mx plus b, I'm going to find the y-intercept for this line and the x-intercept for this line, and then I'll just be able to connect the 2 points. So the y-intercept, when I want the y-intercept, that means that x is 0, because on the y-intercept, the x point is always 0. So if I fill in 0, I get that y is at 20. So I know that I need the point 0, 20. For the x-intercept, I'm looking for where it crosses the x-axis, and the y is always going to be 0 when it crosses the x-axis. So I'm going to fill in 0 for the y, and if I fill in 0 for the y, I find out that x is 20. So my second point is the point 20, 0. So now I have the 2 points, the x-intercept and the y-intercept, and now I can graph them and connect them. So I'm going to go back over to the paper. I need the point 0, 20. 0, 20 is going to be right up there. The point 20, 0, 20, 0 is going to be right here. So now I want to look at the line. I want a dotted line, and I want a shade below. So dotted line, shade below. So I'm going to use my paper again. So I need a dotted line, or really a dashed line, I guess, technically speaking. So there's my dashed line. And to show that I'm working, oops, let me get my color pencil, working less than 20 hours, I'm going to shade below the line, which is going to be all of this. So all of this is shaded below the line. So hopefully you remember with systems of inequalities, what we're looking for is the overlap in the shaded area. So here's how we're going to analyze this right now. Let's go back and remember that we called the x-axis the babysitting. So over here, this is the hours that we were babysitting. And the y is when we were a cashier. So these were our, oh gosh, hours as cashier over here. Okay, so our orange line shows that we want to make more than $90. So if we want to make more than $90, we have to be in this part up here. If I was live with you, I would ask you what the meaning of the solid orange line would be, and hopefully you would tell me along that orange line is when you would make exactly $90. So since you want to make at least $90, you want that orange line or above. However, maybe because you're a student, you're going to school, you have other stuff going on, you want to work no more than 20 hours each week. So what that means is that you have to work less than 20 hours. Well, this is all of the time that is less than 20 hours. So what we want to look for is where would you be making more than $90 but working less than 20 hours, and that's going to fall right in this area right here that's shaded in both colors. So to give an example, maybe I want to do 10 hours of babysitting and 8 hours as a cashier. So 10 hours babysitting and 8 hours as a cashier would make me more than $90, but I would be working less than 20 hours. Maybe I want to do all cashiering and no babysitting. Maybe I prefer babysitting, so I'm going to babysit for 16 hours and cashier for 2 hours. So anything along that line in there, that area in there, is a possible solution.